On to problem 5 of the MIT integration B qualifying exam, 13. The definite integral from x equals to 0 to x equals to 2 of the square root of 12 minus 3x squared. So let's see how we may be able to solve this. So this is our problem. Let's see now maybe how we may be able to solve it. Integration from x equals 0 to 2 of the square root of 12 minus 3x squared dx. Okay, so the important bit here is that I think we want to deal away with the integration sign, and when you do that, you want to do it carefully. The common thing that we're always told is when you see a square root sign, you see a square, you may want to look at a function like sine theta or so. But we want to do it such a way that this part also has a constant that is 12 so that you can factor it away. And so the only way we can do it is by saying let x be equal to 2 sine theta, right? Such that dx d theta be equal to 2 cosine theta, and that means that dx is equal to 2 cos theta d theta, right? And so also looking at the limits, so we have x and we have theta. When x equals to 0, 0 divided by 2 is 0. The arc sine of 0 is 0. When x equals to 2, 2 divided by 2 is 1. The arc sine of 1 is pi over 2. Now that means that our integrals from x equals to 0 to 2 of the square root of 12 minus 3x squared, same as the integral from 0 to pi over 2 square root of 12 minus 3 in bracket 2 sine theta all squared, and then we have 2 cosine theta, right? Let's keep going. So we've our integration 0 to pi over 2 square root of 12 3 2 sine theta squared 2 cosine theta, so which is equal to 0 to pi over 2. This becomes 12 minus 12 sine squared theta 2 cosine theta theta. So we pull out the square root of 12 and we're left with pi over 2 square root of 1 minus sine squared theta 2 cosine theta. So we can pull this out and bring it here. So we have 2 square root of 12, 0 to pi over 2. 1 minus sine squared theta is cosine squared theta. Square root is cosine theta. So we have cosine theta. So this part here, we can pull 4 out so that square root of 4 is 2. So we have 4 root 3, right? And then we can deal with this in the following way. So if you have cosine a plus a being equals to cosine a minus sine a cosine a minus a is equals to cosine a plus sine a sine a, right? And so when you add this together, we have we have cosine a plus a plus cosine a minus a being equal to 2 cosine a, right? And so this is definitely 0, so this becomes 1. And then divide through by 2. We are left with cosine a being equal to a half 1 plus cosine 2a. So this is an important expression that we're going to use. We're going to use it because now we do have an integral for root 3, 0 to pi over 2, and we have cosine theta, right? Which means we have integral of 0 to pi over 2 times a half 1 plus cosine 2 theta, right? And so this becomes 2 root 3 integral from pi over 2 1 plus cosine 2 theta, and that means we have 2 root 3 in bracket theta plus a half 2 theta 0 pi over 2. And as you can see, this part here, 2 pi theta 2 times pi over 2 is pi, sine of 2 of pi is 0, sine of 0 is 0, so this goes 0 for all the limits, and we are left with 2 root 3 times pi over 2, and that means our integral becomes root 3 times pi. So the integral of from 0 to 2 of the square root of 12 minus 3x squared equals to root 3 pi. So that is one way of looking at it. I believe there is another way, and that is by plotting it out. So let's look at the method 2, what I would call method 2, and I would plot it out. So we have integral from x equals to 0 to 2 of the square root of 12 minus 3x squared, right? If you have a plot here, this is x and this is y. At 0, this is root 12, which is 2 root 3, and then a negative 2 goes to 0 at, that is 2. So it's more of an ellipse, but because our integral is only a quarter of the ellipse, and we know area of ellipse to be equal to pi AB, and we see A is 2, B is 2 root 3, so we have pi times 2 times 2 root 3, which is 4 root 3 pi. But this segment is just a quarter the area of the ellipse, so area of interest, or the integral, the integral is equals to a quarter times area of ellipse, which is equals to a quarter times 4 root 3 pi, which is root 3 pi. And that is the required answer. And that's a very short method that didn't require us doing any fancy things.